In the grade 11 chapter Exponents, we start off today revising exponential laws. Here we have our 5 exponential laws. Just a reminder that exponential laws can only be used for multiplication and division, which means only in one term. As soon as you have more than one term, you're only allowed to use it per term. So let's have a look. The first law can be used when you have values that you want to multiply that have the same base. In that case, you can simply add the exponents. So if we have a look at an example, if we have x to the power of 4 multiplied by x to the power of 7, we keep the base x and we simply add the two exponents to get 11. Second law is similar, but now for division. When you divide with the same base, you simply subtract the exponents. So if we now have x to the power of 7 divided by x to the power of 4, we subtract the exponents and we end up with x to the power of 3. Our third law is when we have one base only, but two exponents, and then we simply multiply our exponents. So if we have x to the power of 4 to the power of 7, we multiply those two exponents. 4 times 7 is 28. The fourth and the fifth law is now for different bases. So in the fourth law, we have two different bases, both with the same exponent, and then we simply give that exponent to each base. So if we have x to the power of 2 times y to the power of 3, and all of them to the power of 4, the x and the y's exponent now needs to be changed according to that 4, and we will multiply them according to our third law. So it will be x to the power of 8 and y to the power of 12. And our last law is similar, but now once again only for division. So if we have x to the power of 2 divided by y to the power of 3 and all of this to the power of 4, the 4 has to go to the exponent of x, which will make it to the power of 8, and we divide that by 3 times 4, which is 12. There are also two definitions that are important to remember. First one is anything to the power of 0 is always 1. Second one is if we have a negative exponent. Now, a negative exponent implies that we're actually dividing by that base and exponent. So if we look at an example, this will be helpful if you have 2 to the power of negative 3, which means we are actually dividing by 2 to the power of positive 3, which means we have 1 over 8. Or sometimes the negative exponent can be in the denominator, and to get rid of that negative exponent, we then move it to the numerator and it becomes a positive exponent, and then we have 8. Let's go and have a look at a few examples. In our first example, we have to simplify without the use of a calculator. Now, as soon as you see without a calculator, you can know that you have to use your exponential laws. So in the case of our example, we first need to change the 27 into its prime factors, which means it will be 3 to the power of 3, which is then still to the power of 2/3. Then we're going to use our exponential law, which says we now need to multiply those exponents. Now, just to recap, if you multiply 3 with 2/3, we multiply the numerators and we multiply the denominator, and then that can be simplified to 2. So we have 3 to the power of 2, which is 9. In our next two examples, the question is simplify. Now, when you use exponential laws, there's no order in which you're supposed to use them. It is your preference which one you're going to use first. So in example 2, I'm going to start off by applying the exponent minus 3 to every single base. So that means it will become 2 to the power of negative 3. Then it will become x to the power of 3 to the power of minus 3, which will be minus 9 because I multiply my exponents. The denominator, I have 5 to the power of negative 3, and then y to the power of 12, because once again I multiply my exponents, minus 4 times minus 3. Next up, I'm going to change all the negative exponents to positive exponents. The only one that's already positive is my y to the power of 12, so that stays where it is. The 2 to the power of negative 3 moves to the denominator to become positive 3, and the same goes for x to the power of negative 9 moving to the denominator. 5 to the power of negative 3 moves to the numerator. Last thing I need to do is now expand those constant values. So 5 to the power of 3 is 125, and 2 to the power of 3 is 8, along with the x to the power of 9 and y to the power of 12. Before we look at example 3, I'm going to remind you that you can switch between root form and exponential form. You can do this by changing the type of root into the denominator of the exponent. So if we have a look at the example of fourth root of x, of course at the moment the x has an exponent of 1. We can rewrite this in exponential form by changing the fourth root to a denominator of 4 in the exponent. Let's now have a look at example 3. In example 3, our first step will be to change the root to an exponent form. So everything inside the root will now become to the power of a third, as it was a cube root, and this all still needs to be multiplied by x to the power of a third. So now everything in the bracket has to become to the power of a third. So in the same step, I'm going to change the 8 to 2 to the power of 3, which will then have to become to the power of a third. And similarly, we're going to have x to the power of 2 times a third. Quick reminder again, 2 times a third, we multiply the numerators, we multiply the denominators, so it's 2 over 3. Same thing goes for y, it will be 6 times a third, multiplying numerators, multiplying denominators, and then we can simplify to y to the power of 2. Then we multiply all of this by x to the power of a third. Now in my next step, for the base 2, I'm going to now multiply those exponents. And if I multiply those exponents, 3 times a third, it can be simplified to 1. So it's 2 to the power of 1. Then for my x's, I have 2 bases of x, and I'm multiplying them. And the law then states that we add those exponents. So 2/3 plus another third is 3/3, which is also x to the power of 1 and y to the power of 2.